All right. So I would like you to look at this neural network first of all and make some understanding about it. Okay. I'll do slight modification than what we had yesterday. Right now, what I'm saying is, so first of all, you understand that this is a deep neural network where you are having two hidden layer, one input layer and one output layer. Okay. This is your output, right? So this neuron, it is giving you an output, right? And after that, we are computing the loss. Okay. First of all, you tell me, are you familiar? Are you absolutely clear with the process that we are following while training the neural network?
Yes.
Okay. Now we will go one step deeper to it. Okay. So what I said yesterday was, if this is a deep neural network, if I want to update my this weight, okay. So what it would be, I have to somehow I have to calculate y cap by W1 to 1, right?
Yeah.
Okay. Now by chain rule, let me write the expression first, then I'll talk about it, what I'm writing here. If I have to do some nomenclature here. This is what? This is a this is a 2 2. This is H 2 2. Okay. So
And also, the y cap should be on the right side, right?
no. As I said, my neural network is till this part only. This is not a part of neural network. Here I'm just computing the loss, right?
Okay.
So
That's
so
not a new.
no, that's not a neuron. Let me. I don't know why I have connected this. This is your neural network. Okay.
Okay.
And this is your output node, and this is generating the predictions. Okay, so in order to compute this one, I need to take the partial derivative of my output neuron with respect to W1 to 1, right? Now by chain rule, what I can write here is here 3 1 A3 1 do A3 1. A2 2, and this is what? This is H1 2. Wait, let me rewrite this one. This is getting very hodgepodge. Okay. Can anybody help me writing this expression from chain rule?
Yeah. So it will be dy plus d
See,
W1 to 1.
yeah.
dy.
See, first of all, we have to do this nomenclature, right? I want you to, like, give your full attention here, because if this part you understand, the entire back propagation is at y. Okay. So what this part will be? This part will be A1 2. This part will be H1 2. This part will be A2 2. This part will be H2 2. This part will be A3 1, and this is the output only, right? With this nomenclature, you are clear, right?
I'm not clear with that A31. Why does A31?
See, I told in the previous class also, every neuron, there are two things happening. One is the aggregation part, and then we are applying sigmoid function.
Yeah.
So here in this part, in the left hand part, A1 2, what it is doing first of all aggregations. After applying sigmoid neuron, it is becoming H1 2,
Yeah.
right? The same thing will happen here also. First of all, we will aggregate all the input that we are getting from this neuron, and this neuron. That is what? That is my A3 1. After that,
No,
I'm
but why you're saying it is A31? Because in the beginning you're saying it is A12, then it is A22,
Hmm.
then it is A.
Because
Why
in
it is
the
A?
because in this output layer, I'm having only one neuron, right? Here it is A22 because I'm talking about my second layer, and from this second layer, this is my neuron number 2. Here, this is my output layer, which I can write as A3, and here there is only one neuron. That's why it is A31.
But 3 is because of the layer number 3.
Yes, 1, 2, 3.
Yeah, so it is the layer neuron and layer neuron and input source, right?
Yes, that is with respect to weights. That you are
Okay.
saying, that is with respect to weights. Here, this is not weight. This is, see, after weight, what it will do, we will be doing the aggregation of weight
Yeah.
across this one, right? So
Yeah.
what that aggregation is called? That aggregation is called A12.
Okay, it's called A12. So the A12 it's called because it is the first layer, so it is 1. It is second neuron, so it is called 2.
Yes,
Right?
yes.
Okay.
Here,
Then it's, yeah.
here, if you want to understand what is A12, A12 is what? A12 is your, here if suppose I'm having only x dot W121. So this is my A12. And when I applied sigmoid function on this, when I apply sigmoid function, it becomes H12. And here I'm applying sigmoid.
So similarly, Ashutosh, then the above one will be A11, right?
Yeah, this will be A11.
Okay, and then below will be A13 and then A21, 22, 23, like that.
Yes, yes, yes. But right now, I just want you to focus on this line. Okay,
Okay.
okay. Now, this is what? This is dy cap A31 dot A31 do
H22.
H22 dot do H22
A-
A22 H22
H12.
no, A22, right?
Yeah. Oh, yeah. A22, sorry.
A22,
And then H12.
then H12 H12 and then A12 H, sorry, not H, A12 and finally W121. So from the chain rule, this is the way I can compute the derivative of this with respect to delta W121. If you want to check whether your this expression is correct or not, you can see that if you can cancel it out, right? This will get cancelled with this one will get cancelled with this one will get cancelled with this one, and ultimately you'll see that you will be left with this derivative part, right?
Yeah.
Okay. So if I give you all the values of weights and biases, this thing we can compute, right? Then it's nothing but it just like putting a value of derivatives, right? Now what I said is, right now I asked you just to focus on this one, on this red line, right? But see, the effect of this neuron will have effect on this also, this also, this also, right? So what we do is, we first of all we tried to see what are the different possible route between the neuron and my target neuron, right? And we compute the derivative for that route. So we have identified one route, that is if I want to reach y cap from this particular neuron, this is a one route, right? And I have written an expression for that, how to compute derivative of it. Now, there is another route also. I could have gone from this way, then this way.
Yeah.
I could have gone from this way to this way,
Yep.
right? So similarly, you have to write expression for these two routes also. So you'll see that here, this what A22 we have written, this A22 will get replaced with A21, right? This will be H22. This here in case of A22 will get replaced with A3, A23, H23, right? So similarly, you can route for the expression for
Now
the
the top one should be 2-1, right? H21.
H21. Yeah, sorry, H21. Yeah. Okay.
Yeah.
So you can write the expression for the other two route also, right? Now you'll have total three values at that. One value corresponding to each route. You need to add all those three value, and then the resultant value we will subtract with this W1 to 1. Is it clear?
What do you mean subtract? I didn't. We are taking derivatives, right?
Yeah. So derivatives we have to subtract with this one, right? What was our formula of gradient descent? W is equals to W minus eta
Minus.
d
Yeah.
dl by dw. We
EW.
have
Yep.
computed this dl by dw for each of these three route, right?
Yes.
After that, what we do is we sum the all the dl by dw for all these three route, right? I'll get one dl by dw net. I'm calling it net, which is a summation of dl by w for each route.
Yeah.
I'll multiply that quantity with my eta. Eta is nothing but learning rate. That is something we provide from our end. It can be anything, right? Typically, the value of eta is 0.01. We multiply by with eta, and then we subtract the resultant value with this w. Here, in case of w, we are having w1 to 1,
Yeah. Yeah.
and that will be counted as one update.
Yep.
Right? This process we have to keep on doing for 1,000 times, and that is called epoch. And epoch is something we provide while training our model as an argument. Okay.
It will iterate, right?
It will iterate. So the way you have done update for one neuron, similarly you have to do update for rest or other neuron also. Did you comfortable with this? Are you absolutely clear what I just wrote and what I just told?
Yeah.
Yeah. So this entire process is called backpropagation algorithm.
But just one question. So this is the rule, right? That f- every path will be followed and the derivatives will be taken, and then that respective neuron, all those derivatives will be added.
Yes.
So that will apply to every neuron. So the one neuron which is at the top, all the paths leading to it from
Yes.
y cap, right? Okay.
Yes, exactly. Now, if you will take example of this neuron, right? So there is so this is output node, and this is the hidden layer node. Now there's only one possible combination between these two nodes, right? So we will have only one value of dl by dw. Like the way we had here three routes, I'll just have one route, which will be this one.
Because it is not going further on the left, right?
Yeah, exactly. Right. If suppose I take this neuron, right? So you'll see that there are multiple ways of going from this neuron to this neuron. One way is I can take a path like this. One way I can take a path like this. Other way I can take a path like this. First of all, go this neuron to this neuron. Then again
Yeah.
three routes, right? So again you will have a dl by dw with respect to each route for each route, and then you will sum it up, and then you will perform your gradient descent, right?
Yeah.
Okay. So if in case any interviewer asks you, can you explain me back propagation? you can just draw a simple neural network. You can, it will explain this part, then you have done a great job. Okay. And trust me, this was not really easy to understand because I mean, I have gone through a lot of videos and lot of tutorials just to understand this thing in a simpler way. Otherwise, if you go for some literature and books, they present this thing in a very, very complicated manner. They will use 100 types of notations. They will, put things in a very complicated way. So if you have understood this,
Yeah, I also felt, that the notations are actually can confuse.
correct.
Since we are hearing the class from you, it's making it much easier to understand it.
Yes, absolutely. See, we are using here del, right? Consistently, we have used a del for a partial derivative. In some books, you might see that instead of using this do or del, uh, they write something like this, or they might write something like, this also. So you might also find in the same book in one chapter they have used this notation, in the next chapter you'll use it, they will use this notation
Yeah.
without actually explaining that they both are same thing. Because as an author also, they do not come up by themselves, right? They will follow a lot of blogs, they will do a lot of reviews of different papers, and they'll just scrape the materials from each of the content and try to combine them together and becomes a book. So even from the places where they're scraping the materials, they, those materials are also coming from n number of authors. So they, all authors have their own way of putting the things, right? So that's why it becomes very difficult if you are trying to understand this concept from some books or some, a video. Okay, this is clear, right?
Yes.
Okay, now this is something for you for doing the exercise, right? What I want is, whatever things that we have seen here, uh, try to write this chain rule by yourself, like the way we have written here, right? Try to write this same chain rule for if you want to update this particular weight, W2
Which one?
to,
W22.
yeah. So although the answers are there, but still I would request you to not look at the answers. Give yourself 20 to 30 seconds and try to come up with the answer for this. Okay.
So we have to do that splitting thing like you did, right? Like H11,
Only for
H12.
one route you can take. You can, for now, uh, you just focus on this route, this one.
Okay.
Okay? If you are able to do for one route, then obviously you'll be able to do for all others. I'll just take a pause of for like 20 seconds and then we'll discuss, just to make sure that you have understood this part well, because this is the most important thing in neural network. You, the training algorithm for neural network, and after this there will be only application left. There won't be any theory part to cover.
So that part is already, it's only one step, right? Like DL by DW triple two is nothing but DL A22 into DA22 by DW22, right?
uh, is this you are saying D L
By DA22,
A 2
yeah, into DA22 by DW22.
D A uh, wait, what did you say? D
DW triple two.
equal to, no, actually this is not correct.
But that's what you're asking, right? The arrow that I'm seeing. So you're asking,
I'm asking, see, so this is your, so this will give you y cap, right?
okay, yeah, Y cap.
And once you have computed the y cap, you will do the loss calculation, right?
Mhm.
Now what I want is, you give me the calculation for DL for DA22, because if I want to update, sorry, W triple two. Because if I want to update this value, right, W22, I need to compute first of all the partial derivative loss with respect to this weight, right?
Okay, okay, yeah. Okay, yeah.
So just think here. I'll show you one trick. You know, do not explain this trick to interviewer because logically it will not make sense, but it will give you the correct answer for 90% of the case, and it is very easy to understand. Here, what is on which value my this y cap is depending?
A3.
A31, you write. Okay, for better understanding. Third layer, only
Third
one
layer,
neuron.
first neuron, one
Yeah,
neuron, yeah.
I could have written A3 also because it's only one neuron, so no need of talking about the node part. Okay. Now just think that what on which particular value this A31 depending. It is depending on your what? It is depending upon your
H22
yes H2.
and H21.
Yeah, but before actually going to H21, what is other thing it is depending? It is depending upon A22 also,
Yeah, it is depending on A22 also, yeah.
right? And what on which factor this A22 is depending?
W triple two two.
Yeah, W triple two. The moment we have reached W triple two, you need not to go, uh, you know, beyond that because that is what we are looking for, right?
Yeah. Yeah, so it is going to be dy cap by dA31 into dA31 by dH22.
Yeah, but before that there will be one more iteration. We are computing this loss with respect to y cap, right? So this loss computation will depend upon my y cap also, right?
On y cap.
Okay. Yeah, actually you are correct, saying exactly correct. Just keep on saying.
So dy cap by A31,
Yes,
dA31 into dA31 by dH22
yes.
into dH22 by dA22
Hmm,
into dA22 by dW triple two.
correct. You're absolutely correct. Right. So that would be the exact expression we will be writing. Okay. Everybody have understood this thing? Nazma, Zara, Soumya, is everyone clear on this part?
Yes.
Okay. Any questions and any counter logic for this? If nothing, then let's proceed. Okay. Now this is a part I would like you to take as a homework. Same thing. So now what I have done is I have given you the value of W1 and W2. Okay. Now I just do not, I don't want just the expression. I want the answer for that. What will be the final value after, computation? I have the answer here. I have not mentioned the, steps deliberately so that if you'll try, if you're not able to figure it out, it will take tomorrow. But at least give some time to, you know, uh, arrive at this position. How would you calculate, first of all? Let me give you a hint here. How would you calculate here y cap? This y cap we are calculating from forward propagation, right?
Yeah.
Right. Once you have understood the forward cap, I mean y1 cap, you know y1 already. That is a ground truth,
Yeah.
right? Right. If you know this thing, you have already figured out a dl by dy1 cap.
Yeah.
How exactly I'm getting this expression? By evaluating this. If I'll solve this thing, right, I'll be getting this one.
Hmm.
If I'll solve this thing,
Hmm.
this is something which is coming from the chain rule. If I'll solve this one, I'll be getting this value. I want you to figure out how from solving this equation you're getting this value.
So once you get the product of those three derivatives, you'll apply that on the left side, and then
Mhm.
you will get the y cap, right? Because we know y1.
No, y cap.
Uh,
I will not be calculating with this y cap for computing y cap. I'm using forward propagation, right? Why am
yeah.
the result of this computation, it will help me to update the weights. whatever answer I'm getting, let's say that I'm getting an answer of alpha. Alpha is my answer. I'll use this alpha value to update my weight. So here, this expression is for W212. Now, how I'll update W212 minus eta into
Alpha.
alpha, right? So this value will substitute here, and this eta is something which we provide from our side.
No, but why substituting that value there? Because uh, why are you substituting that value? I don't understand. I don't get that.
What, see, okay. What is the value here used to be? DL by weight. This is the standard equation, right? This is the equation for which is coming from the gradient descent.
It should be W212,
Yeah,
right?
W212.
Yeah.
Right. Once you
Yeah.
have figured out this part, you'll put the
Yeah.
value of it, right?
Yeah.
See, and how I'm getting this value? I'm by the chain rule. When you will evaluate this chain rule, whatever value you'll be getting, you'll be putting here,
Yeah.
right? And then you will compute this new W212.
Yeah, but how I'm calculating that chain rule, right? Those are derivatives. So
Yes. So if I give you these values, right, you will be able to figure out what the values of it. So that is what I'm saying you. Just try to understand, just try to do it yourself today. How would I compute this derivative, right? Ultimately what I want is I want to have some numerical value for this one, right?
but you have not given x1, x2, x3, x4, right? Oh, you have given on top. Okay.
W1, W2 I have given, X I have given, Y I have given. That's all we need,
Okay.
right?
Yeah, but see y, right? Y1 will be 1, right? In this case,
Y1 will be 1.
because you're highlighting the first neuron, the neuron on the
Yes,
left.
yes, yes. It will be 1 only. Yeah.
Okay. Okay.
You understood what I am trying to ask here, right?
You're asking the value of DL by DW212, right?
Yes.
Because that value will tell how much the weight value has to be adjusted
Correct.
based on that.
Correct. Correct.
And then you're saying the DL DW can be calculated by what the formula that you have shown.
Yes.
But see, once I get that value, right?
Hmm.
Once I get that value, why are you drawing that arrow there? That I didn't understand. Because once I get that value, I will just do the subtraction, right? But why are you connecting that arrow with the -2 y1 y cap?
This one you're saying?
Yeah.
Yeah. Okay. Do not look at this part for now.
Yeah,
Okay.
that I understood. That you calculate DL D2 and
Yeah.
2 and
Yeah.
then just apply to this
I'll,
formula
yeah. Yeah.
to give you the difference.
Once you'll compute this one, then I will tie your result with this expression that is written here. Actually, there are some steps in between this which I have uh, not you not mentioned. That is what I want you to figure out. Once you have this expression, right? How would you compute this expression to get the numerical value? That is the thing that you have to do.
Okay. So this we should do in Python, or we can do this
You can
even on paper, right?
you can do in paper also, because this is a very shallow network, right? It's just one
Yeah.
hidden layer. You can do this.
Okay.
So try to do today. If you're not able to figure out, tomorrow anyways we're going to see it.
Okay.
Okay, because the reason why I'm not explaining this is because this is simple plain elementary calculus, right? And there's nothing that I can teach you there, uh, at least in terms of calculus part. This chain rule was important, which I told you. How to update the rules I told you, but doing the calculus part is something that you have to figure out. Okay.
Okay.
All right. There was another piece which I wanted to discuss with you, but I don't think we have time for that. Let me give you a quick overview of it. Okay. So far, whatever we have done, it is a part of classification, right? Always we want we have written a code for classifying images or record. right? Now today, what we will do, we will write a small code for object detection. Okay. So what I meant by saying object detection is, if suppose in input you are giving an image, right? An image you have given, in that image there is some sign is there, stop sign is there. You want to identify where that stop sign is, and you want to draw a bounding box. This is called object detection and object localization. First of all, what it will do, it will identify all the desired object in that image frame, and then it will draw bounding box on that. So detection plus localization, you have to localize where exactly that object is. Okay.
So isn't detection doing the work of localization only? Why are you separating them? I didn't understand that.
See, if you are just seeing the detection, okay, so what it will, first of all, it will detect whether your desired object is there in that image frame or not.
Yeah.
So that is a detection part. You have detected, but you, to localize it, you need to draw some bounding box, right?
So you're saying that drawing the box is localization.
Yes.
Just detection does not draw the box.
Yes, just detection, it will just spot the object and it will highlight that name, but we do
Okay.
not know on which particular part of that image that object is lying.
Okay, got it.
Okay, so for that we are going to use one of the very popular library that is called OpenCV. Okay, Open Computer Vision, and this is a part of computer vision problem. Okay, and you know and today we are going to use a very primitive algorithm for doing it, and this algorithm is called Har cascade, HAAR. Some people pronounce it har. I used to call it, I'm saying it har cascade. Okay, I'm not going to explain you the working of this algorithm. We're gonna use it as a black box, right? But I'll tell you what is the input for this algorithm, what is an output of the algorithm, and how in a high level how this algorithm works. Okay.
Yeah.
Today you said like, excuse me,
Mhm.
like today, like we are supposed to do this back propagation, right? Using chain rule.
That's what we
Did
did,
you
no?
finish? Yeah, we did, but you said like you'll give the algorithm how it works.
That is the algorithm. You, I mean, we did it for one node. Similarly, you have to do for all the nodes, and you have to keep on doing by the number of epochs we provide in the code, right? So backpropagation is what? It is a continuous forward and backward pass. First of all, okay, let me summarize this one more time for you. And Mhm.
Why we need the chain rule to minimize the loss?
No, chain rule is required because we cannot directly compute my partial derivative of loss with respect to W, which is in the very starting layer, right? Because the effect which I'm getting in the output loss, it is propagated through series of nodes. That's why we have to come step by step backward.
Okay, but we have not completed, right, properly.
Anyone else think that? I mean, anyone have any doubt on that part, or shall I summarize it well one more time?
The back propagation?
Yeah.
Yeah, I think I mean I understood it, but if like if you want to
Okay.
summarize for everyone, then I think it will be good for me also. It will be a revision.
Okay. Cool. Let's do it in this another call. Okay. This
Okay.
is going to expire.